The content will go in-depth about helicopter types, their components, and flying tips. Understanding helicopters, types, mechanics, and how they fly. Introduction. Welcome to today's video. Helicopters are incredible machines, used for a variety of purposes ranging from military operations to civilian transport. In this video, we'll explore the different types of helicopters, break down their working parts, dive into the mechanics of their engines, and give you some tips on how to fly one. Stick around to the end for tips on how to check and maintain a helicopter's engine and other vital parts to keep them in top working condition. Types of helicopters and their categories. Helicopters are highly specialized aircraft designed to perform specific tasks. They come in various shapes, sizes, and capabilities depending on the mission at hand. Let's break them down into different categories. Military helicopters. Military helicopters are designed for a wide range of tactical roles. They are built to withstand harsh conditions and carry out dangerous missions. Attack helicopters. These are heavily armed and armored helicopters designed for combat operations. Examples include the AH-64 Apache and the AH-1 Cobra. Their primary role is to engage enemy ground targets, such as tanks or infantry. Transport helicopters. These helicopters are used to carry troops, equipment, and supplies. Some of the most famous models include the Sikorsky CH-47 Chinook and the Boeing CH-46 Sea Knight. Reconnaissance helicopters used for gathering intelligence, surveillance, and reconnaissance ISR. The Bell OH-58 Kiowa is a prime example of this type of helicopter. Search and rescue SAR helicopters. These helicopters are equipped for rescue operations, typically in hazardous conditions. They are often used for saving people in distress, such as after a natural disaster or on the battlefield. Exploration helicopters. These helicopters are used for scenic tours, remote area exploration, or research missions. Tourist helicopters. These are typically smaller, lighter helicopters used for sightseeing or tourism purposes. The Bell 206 Jet Ranger is commonly seen on these types of missions. Research helicopters, used for scientific research and environmental studies. These helicopters may be equipped with special instrumentation for collecting data, such as on weather patterns or wildlife tracking. Rescue helicopters, firefighting helicopters. Firefighting helicopters are specifically built to fight wildfires, dropping water or fire retardant on fire hotspots. Water-dropping helicopters. These helicopters are equipped with large buckets or tanks to scoop up water from lakes or rivers to drop onto wildfires. The Sikorsky S-61 and CH-47 Chinook are examples of such helicopters. Fire rescue helicopters. These helicopters are used in areas where fires may put lives at risk, evacuating people from danger zones or helping with search and rescue missions during large-scale fires. Civilian and transport helicopters. These helicopters are used for civilian purposes, such as air travel, corporate transport, or cargo delivery. Rescue helicopters are often equipped with life-saving equipment to perform emergency medical evacuations and disaster relief operations. Medical evacuation medevac helicopters. These helicopters are equipped with stretchers, medical equipment, and sometimes even a full medical team to transport injured or ill individuals. Examples include the Eurocopter EC-135 and the Sikorsky S-76. Search and rescue SAR. These helicopters are designed for searching for missing persons or responding to emergency situations in difficult terrain or hazardous conditions. Firefighting helicopters. Firefighting helicopters are specifically built to fight wildfires, dropping water or fire retardant on fire hotspots. Water-dropping helicopters. These helicopters are equipped with large buckets or tanks to scoop up water from lakes or rivers to drop onto wildfires. The Sikorsky S-61 and CH-47 Chinook are examples of such helicopters. Private and executive helicopters, used by wealthy individuals or executives for quick transport. These helicopters are luxurious and often come with customizations for comfort and efficiency. The Airbus helicopter's H145 is a popular model for this purpose. Cargo helicopters used for transporting large or heavy cargo, sometimes in remote areas where other vehicles can't reach. The Chinook and the Sikorsky S-61 can carry large loads, such as construction materials or oversized equipment. The inner workings of a helicopter's engine. Understanding how a helicopter works involves looking at its engine and mechanical systems. Most helicopters are powered by turbine engines, similar to jet engines but optimized for vertical flight. Let's break down the key components. The engine. The engine is the heart of a helicopter, converting fuel into mechanical power to drive the rotor blades. Most modern helicopters use gas turbine engines because of their high power-to-weight ratio and efficiency. These engines work by compressing air, mixing it with fuel, igniting the mixture, and expelling the exhaust to generate thrust. Main rotor drive system. The engine powers the main rotor through a series of gears and a transmission system. The main rotor is what generates lift and allows the helicopter to stay airborne. Tail rotor drive. The tail rotor is powered by the engine through a separate system, and it's used to counteract the torque from the main rotor. This prevents the helicopter from spinning uncontrollably. Main rotor and tail rotor. Main rotor. The main rotor is responsible for generating lift. It consists of large blades that spin rapidly, creating a pressure difference above and below the blades. This pressure difference generates lift and allows the helicopter to rise vertically. The blades can change their pitch to control the lift and direction of the helicopter. Tail rotor. The tail rotor counteracts the torque produced by the main rotor. Without the tail rotor, the helicopter would spin uncontrollably in the opposite direction. The tail rotor is also used to control the yaw of the helicopter left and right movements. Transmission system. The transmission system is responsible for distributing the engine's power to the rotors. It includes the main gearbox, which adjusts the speed and torque from the engine to the main and tail rotors. The gearbox also ensures the correct synchronization between the engine and rotor blades. Fuselage. The fuselage is the body of the helicopter, housing the cockpit, engine, cargo area, and passengers. It is designed to be lightweight yet durable, able to withstand the stress of flight while keeping the helicopter agile and efficient. Modern helicopter fuselages are often made from composite materials to reduce weight and improve performance. Cockpit. The cockpit is where the pilot controls the helicopter. It contains all the flight instruments, including the altimeter, airspeed indicator, compass, GPS, and engine monitoring systems. The controls in the cockpit are sensitive, allowing for precise adjustments in altitude, speed, and direction. Landing gear. Helicopters typically use either skids for smaller helicopters or wheeled landing gear for larger models to land. The skids are lightweight and minimize weight, while wheeled landing gear allows for easier takeoffs and landings on hard surfaces. How to fly a helicopter. Basic tips. Flying a helicopter is a complex skill that requires a combination of control over the main rotor, tail rotor, and other systems. Here's a basic rundown of how to control the helicopter during flight. Collective pitch control. The collective is the lever in the cockpit that adjusts the pitch of the main rotor blades. By increasing the collective, the pilot increases the lift and causes the helicopter to rise. Lowering the collective decreases the lift, bringing the helicopter down. Cyclic pitch control. The cyclic is the joystick that controls the helicopter's forward, backward, and lateral movement. By tilting the cyclic forward, the helicopter moves forward, and tilting it to the side causes it to move sideways. Anti-torque pedals. The anti-torque pedals control the tail rotor, adjusting the yaw of the helicopter. Pressing the left pedal turns the helicopter left, and pressing the right pedal turns it right. Hovering. Hovering is one of the most challenging aspects of flying a helicopter. To hover, the pilot needs to balance the collective, cyclic, and pedals to keep the helicopter stationary in the air. It requires constant adjustments to maintain the position. Takeoff and landing. Taking off involves gradually increasing the collective to gain lift, while the cyclic is used to control the direction. When landing, the pilot reduces the collective to descend slowly while using the cyclic and pedals to maintain control of the helicopter's position. Maintaining a helicopter. How to check the engine and other parts. Regular maintenance is crucial for keeping a helicopter in top condition. Here are some tips on how to inspect the engine and other key parts. Engine check. Before each flight, the pilot or maintenance crew should check the engine for any signs of damage, such as oil leaks or unusual wear. The oil level should be checked, and the air filters should be inspected for cleanliness. A thorough engine inspection can help prevent failures in flight. Main and tail rotor blades. Check the main and tail rotor blades for cracks, dents, or any other damage. The blades should be properly balanced and free of any debris that could cause damage during flight. Transmission and gearbox. Inspect the transmission system for any signs of leaks or wear. Ensure that the oil levels are correct, and listen for any unusual sounds during the flight. Hydraulic system. Helicopters use a hydraulic system to control various parts, including the rotors and landing gear. Check the fluid levels regularly and inspect the system for leaks. Flight controls. Check the flight controls, including the collective, cyclic, and pedals, for smooth operation. Ensure that they are free from any obstruction and function properly. Landing gear. Inspect the skids or wheels for any signs of wear or damage. Ensure that the landing gear is properly lubricated and free of any debris. Helicopters are incredible machines, capable of performing a variety of tasks, from military operations to life-saving rescues. Understanding how they work from the engine to the rotor blades can give us a greater appreciation for these amazing aircraft. Whether you're interested in flying or maintaining helicopters, it's essential to keep an eye on the engine and all the working parts to ensure safe and efficient operation. Timing in turbine engines. Turbine engines commonly used in helicopters operate differently from piston engines. Timing in turbine engines refers to the synchronization of fuel delivery, air compression, and ignition to ensure continuous combustion. Here's how timing is set and managed in turbine engines. Fuel Control Unit FCU. This is the core component that regulates the timing of fuel delivery into the combustion chamber based on engine speed, pressure, and pilot input. It ensures the right amount of fuel is delivered at the right time for efficient combustion. Ignition system timing. Turbine engines rely on spark igniters during startup to ignite the fuel-air mixture in the combustion chamber. The timing of this ignition is controlled by the engine startup sequence and is automatically managed by the FCU and electronic control systems. Continuous combustion. Unlike piston engines, which have distinct power strokes, turbine engines have continuous combustion. Once started, they do not require constant ignition timing adjustments because the combustion is self-sustaining as long as fuel and air are supplied. Tail boom, the long structure that supports the tail rotor. 3. Fuselage. Cockpit contains the flight controls, instruments, and pilot seating. Cabin, space for passengers, cargo, or mission-specific equipment. Skids or landing gear supports the helicopter during landing and on the ground. For power plant or engine. Gas turbine engine. Most helicopters use a gas turbine engine for its power-to-weight ratio. Components include compressor, compresses incoming air to high pressure. Combustion chamber, mixes fuel with compressed air and ignites it. Turbine, extracts energy from the hot gases to drive the rotors. Exhaust, expels the remaining gases out of the engine. Piston engine. Smaller helicopters, some helicopters like the Robinson R-22, use reciprocating piston engines. Engine timing parameters. Example, flow and turbine RPM are calibrated during manufacturing and maintenance to ensure optimal performance. Modern turbine engines may use FADEC full authority digital engine control systems to automate and optimize this process. Parts of a helicopter. A helicopter is made up of several major systems and components, each with specific roles to ensure safe and effective operation. Here's a breakdown of the main parts. 1. Main rotor system. Rotor blades, long aerodynamic blades that provide lift. Rotor hub connects the rotor blades to the mast and transmits motion. Swash plate assembly allows the pilot to change the angle of the rotor blades for control cyclic and collective pitch. 2. Tail rotor system. Tail rotor blades, smaller rotor at the tail to counteract the torque of the main rotor and provide directional control. Tail boom, the long structure that supports the tail rotor. 3. Fuselage. Cockpit contains the flight controls, instruments, and pilot seating. Cabin, space for passengers, cargo, or mission-specific equipment. Safety should be your top priority. Also, review your flight plan and weather conditions to avoid unexpected challenges. Regularly scheduled maintenance is essential to prevent mechanical issues and ensure the longevity of the helicopter. Always respect the complexity of the aircraft. Your life and the lives of others depend on your attention to detail. Comparison: piston engines versus helicopter turbine engines and why timing is different. 1. Piston engine. Automotive, smaller helicopters. Piston engines, also called reciprocating engines, use a series of controlled explosions in cylinders to generate power. The key features include ignition timing, controlled by a spark plug that ignites the air-fuel mixture in each cylinder. Timing is critical and must be synchronized with the movement of the piston in the combustion cycle: intake, compression, power, and exhaust. The timing is measured in degrees of crankshaft rotation and is adjustable for performance and efficiency. Applications: used in smaller helicopters like the Robinson R-22. Lower power-to-weight ratio compared to turbine engines, but cost-effective for light-duty operations. 2. Turbine engine in helicopters. Turbine engines are the standard for larger and more advanced helicopters. They use continuous combustion rather than the intermittent explosions of piston engines. Key differences include ignition timing. Timing in turbine engines is less about spark timing and more about synchronizing air compression, fuel delivery, and ignition during the startup phase. Once combustion begins, the process is continuous, so the engine doesn't rely on timing adjustments like a piston engine does. Advanced systems like the full authority digital engine control FADEC automatically manage fuel flow and combustion. Power generation or engine. A turbine engine compresses air, mixes it with fuel, ignites it, and uses the expanding gases to spin a turbine, which drives the helicopter's rotors. Provides a high power-to-weight ratio, making it ideal for lifting heavy loads and high-speed operations. Why timing differs. Piston engine timing requires precise ignition timing for each power stroke. Misfires or incorrect timing can damage the engine or reduce efficiency. The timing constantly adjusts based on the engine's RPM and load, controlled by distributors or electronic ignition systems. Turbine engine timing Timing in turbine engines primarily applies during startup and fuel regulation, not in ongoing combustion. Continuous combustion eliminates the need for a cyclical ignition system, making turbine engines simpler to operate at high RPMs. Key takeaway: the main difference in timing comes from the fundamental operation of the engines. Piston engines rely on cyclical combustion and ignition timing, while turbine engines operate on a continuous combustion process that doesn't require ongoing ignition adjustments. This makes turbine engines more efficient and reliable for aviation, but they are also more complex and expensive to maintain. I hope this video has given you a comprehensive understanding of helicopters, how they fly, and how to maintain them. If you have any questions or would like to know more, feel free to leave a comment below. Thanks for watching, and see you next time.